So the goal of hypothesis testing in general is you're trying to test for a test statistic, so either a t-score or a z-score. So let's do a t-test. You would have a particular distribution that has, like from your sample, you got an average or sample mean, and then you found a standard deviation from that. And so to calculate the t-score, you would do t-score equal to the sample mean minus the true mean. And usually this is be the mean that's given to you by the null hypothesis and divided by standard deviation. So you're doing this to calculate a p-value. And the base idea is you're essentially assuming that the null hypothesis is true, right? So there'll be two hypotheses. Let's say there's a null hypothesis saying that, the mean is actually 5, and the alternate is that it's much higher or not equal to or lower, whatever. But there's an alternate hypothesis contradicting the null hypothesis. And so the idea for the p-value is this is the probability of obtaining a sample that is x bar, probably obtaining of getting something that's basically at this level of value for sample mean or more extreme if the null hypothesis is true. Right, and so the base idea is you're making an assumption, you're assuming that the null hypothesis is correct. If it's correct, what is the particular probability that you would be able to pick out a sample with, some amount of sample mean, whatever sample mean you happen to get. Now, because it's a probability, we can't really do like probably at a single value. It's always the probability of getting that number or more extreme. Right, so if we were to look at a graph of this on a distribution, if this was a sampling distribution for some whatever sample, then let's say your x bar, so we're claiming that the average is 5. So this is the population average. If your sample got a value of somewhere over here, x bar, right, or essentially what we're calculating for the p-value, it's this area here. And that changes slightly if you're doing like two-sided. So if you claim it's just not equal to 5, then it'd be both sides. If it's less, then it'd be to the left of. But the point is the p-value, the lower the p-value implies that it's less likely for this kind of outcome to occur if the null hypothesis is true. So the lower the p-value, in fact, if it's below 5%, 0.05 usually, which is usually the significance level for most testing, if it's usually below that, then you would actually think that it's very unlikely for the null hypothesis to be true. So we would say we reject the null hypothesis, right? Which suggests that you think, okay, we never say anything for sure in stats. Like there's significant evidence that the null hypothesis is false, and but we don't like say, oh, the alternate hypothesis is true on that stuff. But the point is just if you have a low p-value below 5%, you would reject the null hypothesis. We think it's unlikely that the average is actually 5. It's much more likely that the average is actually a little bit higher than 5, or some amount higher than 5. And so all this changes slightly for two sample t-tests. Because the basic premise behind everything is still the same. The key change is now you have two samples. So your null hypothesis is going to be that the average of the first sample is equal to the average of the second sample. Or, in other words, the difference between the two would be equal to 0. Right? So this is your null hypothesis. This is your original claim. Remember, this is the thing we assume to be true while we're doing the hypothesis testing. The alternate hypothesis would be that they're not equal, or one is particularly bigger than the other. So this is not equivalent, but you would say something like, oh, u1 minus u2 is greater than 0 if you think u1 is bigger, or whatever. So when you do this, one of the key changes is before we talked about how the mean for the sample was x bar and the standard deviation was s. But now notice, because we're going to subtract two samples, this is where it goes back to like the early part of the notes. You're going to be looking at x1 bar minus x2 bar as your average. And then we're going to be looking at the standard deviation, which I don't have the formula memorized, but it's that whole mess of a formula with the square root, right? I think it's this thing, the MA. I think this is a notation you guys use. But the point is, it would be based on the standard deviation of the two samples, right? So you have a slightly bigger standard deviation from that, or slightly messier standard deviation from it. So you have to keep that in mind. And then from all this, you're going to calculate a t-score, and then it kind of goes the same idea. You calculate a t-score off of this by using the difference minus the hypothesis, which is the difference should be 0, and then divide this standard deviation thing. So I'm just going to do standard deviation of the two subtracted. Right, and then it goes through the same process. The t-score gives you a p-value, and the p-value is low. We rejected no, but in this case, rejecting the no means that we think there is a significance difference between the two samples, mu1 and mu2. Right, so hopefully that helps.